Hello Science Alliance, I am Lara. I stream free live physics lessons into the internet for your viewing pleasure, and you've just come to the second lesson of astrophysics. You don't need to have seen the first astrophysics lesson to enjoy this one. I'm so excited about it. We get to talk about the solar system. Before we talk about the solar system, we need to talk about gravity, which holds the entire solar system together. And I asked you a question, which I asked them on Facebook yesterday. And like I say, I was delighted to see that a lot of them got it wrong. So let's see if I can teach you something as well. Which arrow correctly shows the direction of the Earth's gravitational pull on Earth? Is it A, the one where the arrow is going in the direction that Earth is travelling? Is it B, where the arrow is going from Sun to Earth? Is it C, where the arrow is going directly downwards in between, sort of from the Earth, but just skimming past the Sun? Or is it D, where the arrow is going from Earth to the Sun? The answer is it's D. If you said C, then you have probably been learning about gravity, and I'm very pleased with you, even though you got the answer wrong, because you've probably learned gravity acts downwards. Gravity always acts downwards. And this is a good thing to know, because when you're doing about forces, which you'll also need to know about if you're doing IGCSE physics, you quite often, physicists are always talking about like boxes on hills. So if this is Earth here, there's some grass, this is a box on a hill. If you ever have to work out the forces acting on the box, you might need to think about gravity, and you would need to know that gravity is acting downwards, right? It's sort of tempting to say gravity is acting like down the hill. That is not correct. That's not what happens. So if you've got in your head gravity acts downwards, then well done. That's a good thing to remember when you're doing questions about things that are on Earth. But it doesn't actually act like downwards. It acts towards the centre of Earth, which obviously on Earth is downwards. But in this situation, we're talking about Earth's gravitational pull. So gravity would act to... sorry, we're talking about the Sun's gravitational pull. I'm going to sneeze. Sorry. So Earth's gravitational pull is acting towards the Sun's gravitational pull is acting towards the centre of the Sun. Okay? Earth is pulling on the Sun, so that's what's happening with B. But D is showing how the Sun's gravitational pull acts on Earth. You've got to be a bit careful if you're answering questions about this. I've been doing quite a lot of past paper questions recently, just to sort of help you to know what you need to learn. And it came up a lot that don't just write gravity. Like, make sure you're talking about what is pulling on what. So say the Sun's gravitational pull or the gravitational pull of Earth. If you just say gravity, the examiner has to pretend they don't know what you mean. So you have to be really specific about what you mean. Make sure you talk about the gravity of what. Okay, so one of the things you need to know about if you're doing an IGCSE physics exam, you might not be, you might just be here for fun. Well done, this is really interesting. But one of the things you need to know is that gravity causes things to be in orbit around other things. Last week we talked about the moon, we get to talk about comets today, and planets and how they go around things. That is because they are getting pulled on by gravity, all right? So it's a nice easy one to start with. Okay, a second slightly tricksy question for you. And then we will do a bit of an activity using this baking tray and some rice. How do the planets orbit the Sun? Well, I'll show you this picture. So this is a very common picture. We talked last week about how it's a bit wrong because the Sun isn't quite at the centre of where the planets orbit. It's just at one side. But that's not what we're talking about in this question. Do you think this classic image of the planets all in one plane around the Sun is correct? Do you know what I mean by plane? Sort of all in one direction. So you could more or less draw a line through all the planets in this picture, and the line would go through all of them. Or is that picture simplified and the planets are actually moving in all different directions like this? So it's kind of like, is the solar system, the planets going around the Sun, is it a flat thing? Or is that a simplified drawing, you know, where you see like the Sun and then all the planets in a row? Is that simplified and the 3D, and it's more a sort of 3D model in reality? It's like a sphere of planets going around the Sun. Again, delighted on Facebook to find I was getting loads of different answers. Well, both different answers to this question. Which one do you reckon? And if you've got the free printouts from my website, you don't have to. I don't assume you've got a printer. My printer is rubbish. But if you can print off printouts and you've got my free optional printouts from my website, then you've got a piece of a blank space next to this question which says, explain your answer. Go on, have a go at explaining. Hopefully, even if you've got the answer right, you can't explain it. Hopefully, because I can teach you that in a sec. Have you got an answer? It's just one or the other, isn't it? So shall we move on? I know, I'm just going to leave you hanging. So mean. And we'll come back to it after we've done the activity, when hopefully you'll have a better idea. You'll be able to tell me. Okay, so I'm going to flip you around. This is a bit annoying, I'm sorry. We're teaching there's like 8 different modules of stuff you need to know to do IGCSE physics. We're doing astrophysics before we've done nuclear, which is when you learn about atoms. So you might know, or you might not know, that an atom is like a positive particle in the middle with negative particles sort of whizzing around the outside. And atoms can be very small, like this is an atom. This is actually an atom of hydrogen, which we will talk about. Or the atoms can get bigger and bigger. You can get more positive particles in the middle, more negative particles around the outside. And there's atoms of all kinds of different things, like aluminium and oxygen and hydrogen. You might know about this. We don't need to talk about it a lot. You just need to sort of generally know what an atom is. If you've heard of the periodic table is a big list of all of the atoms. Okay, I feel like I'm just chucking a lot of chemistry at you, which you don't really need to know. I just don't want to start talking about atoms and you'd be like, what are you saying? I've never heard of an atom. So the periodic table is a list of all of the atoms that exist, from the very small, light ones up here. So when I say element, an element is something that is only made out of one kind of atom. So if something's only made out of hydrogen atoms, then it's an element, yeah? If it's only made out of oxygen atoms, then it's an element. So this is a list of all of the elements, okay? We will learn more about this later. But anyway, the small atoms, or the light elements, are near the beginning of the periodic table, like your hydrogens and your heliums. And the bigger atoms, the heavy elements that have more particles in them, are a bit further down. So here we've got iron. The symbol for iron is Fe, because chemistry is awful, and that's quite a heavy element. Okay, cool. So let's pretend that our baking tray is space. I made up this activity, you know. I think so. Sometimes I forget what I've read on the internet and what I made up, but I think this is one of my makey-uppy ones. If you've got some herbs on you, or some flour, or anything that's kind of light, can you please sprinkle it onto the baking tray? I said to bring a few tablespoons. Like, I'm the teacher, so I can use my oregano for whatever I want. I'm going to put quite a lot of, well, that's a lot. I'm going to put a lot of herbs on my tray. But, you know, ask an adult. Herbs are expensive. Spices are even more expensive. Don't waste all your good herbs on my account. Anyway, put some herbs on the tray. We will say that these are our light elements. This is like your hydrogen, your helium. There's actually a lot of stuff in space. We talk about it as being a vacuum, but there are clouds of stuff floating in space. And most of those clouds, this is important, most of the stuff in those clouds is hydrogen and helium. We will talk about why in other lessons. But this is space, and we've got a cloud of stuff, hydrogen and helium, in space. We need some heavy atoms as well. We don't need as many. So however many herbs or spices you've put on the tray, don't put as many heavy bits on. But if you've got some like pasta or some lentils, I'm using rice, put that on your tray as well. And we'll say that those are the heavy elements. There's not as many heavy elements in these clouds floating in space. They're mainly hydrogen and helium, but they have got a bit of iron, a bit of oxygen, heavy metals, right? Okay, so I think that's all you need to do. And I'm going to show you a little PowerPoint of like a little story about one of these clouds of gas and dust that was floating in space 4.5 billion years ago, all right? And then we'll do a bit more of the activity. Okay, so science words for you. A cloud of dust and gas in space is called a nebula. Did you know that? Well, it is. A nebula is a cloud of gas and dust just floating in space. And like I say, nebulas are made out of hydrogen and helium, but also some heavy elements as well, like your ions, whatever. So we've talked about gravity. Everything that has mass has gravity. So even the tiniest, weeniest little particles have got a gravitational field around them. So what happens is, right, 4.5 billion years ago, the gas and dust particles in a particular nebula start pulling towards each other because they have gravity, just teeny weeny gravity, but they can feel each other, so they start moving towards each other. Here we go. And this makes the particles clump together. And obviously, because they're clumped together, the thing has got more mass, it's made of more particles, so it's got even more gravity, so they pull together more. Oh, what's going to happen next? This is called accretion, by the way. Accretion, stuff sort of coming together. That's an important word. I might ask you to use that later. Accretion, stuff coming together. In this case, tiny particles of gas like hydrogen and helium in space coming together because they have mass, so they have gravity. If you read about this later, if you read stuff to do with astronomy and you see things like a cloud collapses in on itself, that is what this means. It's the particles have got gravitational fields around them, so they all start pulling together. So remember this cloud is called a nebula? When a nebula gets smaller like this, it gets hotter and it starts to spin. Can't tell you how long it took me to do this PowerPoint. Can you see where this is going? Do you know where we're getting at? This is 4.5 billion years ago. Over 99% of all the matter in this nebula pulls together to make a star. This is not unusual. This is actually how stars are born. We're going to do a whole lesson on how stars are born next week, but this is a special, special moment because this one is our star. Yay! So less than 1% of the stuff that isn't the sun kept on spinning, okay? So we've had this big cloud of hydrogen and helium and whatnot. It's called a nebula. It's collapsed because gravity. More than 99% of it has just turned into our sun. So less than 1% of it is just still spinning around the sun like that. And this is the accretion disk. And should we keep going? Yeah, let's keep going. So the matter in this accretion disk keeps pulling together and pulling together and pulling together until eventually the planets form. Whew! Right. Did you get that? Shall we do an activity using our baking tray to talk about how the planets formed and to discover a cool fact about the planets? If you've watched my All Ages Oceans module, which we only just finished, you might know this already, but it'll be good for you. So let's do a model where we've got the sun, which has been made out of 99% of all of the gas and dust particles, the hydrogen, the helium, the iron and whatever. Can we say that the sun is our head? That's probably about right, isn't it? Do you reckon your head weighs like over 99% of what the herbs and the rice weigh? So we'll say that the sun is your head and it's already formed. We'll talk about nuclear in another lesson. But yeah, your head is the sun. It's very, very hot. Really, we should have this tray in like a sort of donut or bagel, depending on what team you're on, shape all around your head. But we'll just say that this is a bit of the accretion disk, okay? This is a bit of the stuff that is orbiting the sun, your head. You need to know how the planets formed, which I could do like another 3 lessons on the science behind how the planets formed. But basically, you know how like your baking tray is made out of metal, right? And it's solid. You know how you're in a room which is about room temperature and metal is a solid at room temperature. You know how even when you put your baking tray in the oven, it stays a solid, doesn't it? Even when your baking tray gets really, really hot, so it burns you, it doesn't melt into a liquid, does it? And it definitely doesn't like boil into a gas. No, metal, even when it's really hot, clumps together and forms a solid, yeah? So, your rice is iron and other metal particles. It's right next to the sun, but it's still able to form a solid. So could you please clump, you might see where this is going, can you please clump your rice or your lentils or whatever together to make some planets? It doesn't matter at all. In fact, it's quite good for the model if you get some herbs or spices in with your planets as well. But I'll tell you what, let's do 4, because there are 4 planets that are nearest the sun that are made out of heavier elements. They are, in fact, do you want to learn them? Do you know them? You have to know the order of them for your IGCSE if you're going to do it. Mercury, Venus, Earth and Mars. So let's make Mercury, Venus, Earth and Mars. This is a pretty good model so far, okay? The heavy elements they can turn into solids even though they're really hot, like right next to the sun. So that's what has happened, okay? I just did it then. What happens is the lighter particles, they can't form a solid really near the sun. Like you might have noticed that in your room now, oxygen is a gas, yeah? If there's any hydrogen and helium in your room, it is also a gas. Hydrogen and helium has to get really, really cold before it turns into a solid. It's got to be further away from the sun. So if you, because the sun, I don't know if you get marks for this in your exam, but the sun is giving off solar wind, right? The sun is giving off a lot of energy. So you can blow if you like. In an exam, you might want to write something like the lighter elements get thrown further away from the sun. So just blow on your herbs is what I'm saying. Trying not to get any of them on your computer. What's happening? Oh, the lighter elements like hydrogen and helium are getting thrown further away from the sun. But the rocky planets are sort of staying where they are, aren't they? Oh, come on, what a great model. So all this is to say, this is why the rocky planets are near the sun, because they are made out of metals which could condense even near the heat of the sun, and the lighter elements had to be cooler before they could condense, which is why the gassy planets are further away from the sun. Phew! Do you want to just see that on a PowerPoint? Yeah, of course you do. Here we go. Metals, we will talk, I feel bad because we're going to talk about condensation and condensing and melting points and stuff like that in another lesson, not as part of the astrophysics module. But basically, metals are solid or have condensed, like become a solid at high temperatures, whereas hydrogen, helium, other particles with hydrogen in, such as like water and methane, they are gases at high temperatures, so they only become solids at very low temperatures, okay? Near the sun is hot, children. Further away, not as hot. So the rocky planets formed from the heavy elements, and the gas giants formed from water, methane, hydrogen, and helium that condense at lower temperatures. Yay! There is, like as our model showed quite nicely, there is some helium trapped in Earth, there are some lighter elements trapped in the rocky planets, and there are some heavy metals in the gas giants, but just generally speaking. So the cores of the gas giants are solid, actually, because they are solid water, methane, hydrogen, helium. Right, so yeah, Mercury, Venus, Earth, Mars, rocky, Jupiter, Saturn, Uranus and Neptune, gassy. So like I say, one of the things you will have to remember for your exam is the order of the planets. I forget that before I started training to be a physics teacher, like in my late 20s, I didn't know the order of the planets, just it hadn't come up. The easiest way I find to remember the order of the planets is to remember Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Honestly, I'm not even joking. Far easier than trying to remember like, oh, a rhyme that has the first letter. No, just Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Just remember it. Right, I've done loads of talking. I need to go and get a glass of water. So here's your question sheet. If you've got the printout, it's a bit easier. You can just fill in the gaps. If you haven't got the printout, you don't need to copy this all out. If you don't want to, just write the words. I've left blanks. Filling in the blanks is the like bare minimum that I want you to do. There's some nice language, some good words that we've said that aren't on this sheet, that if you can mention them, you're going to get some extra marks at IGCSE. So have a look at this, please. And I've put, can you fill in the blanks, but then also, can you just add as much information as you can think of that I haven't put on the sheet. So, a cloud of something, helium and some heavier elements, pulls together because of something, starts to spin, a something is formed in the centre. This happened something years ago and was the birth of our solar system. So solar means sun. The whole solar system is just the stuff that revolves around the sun. Over something of the nebula became the sun. The something formed from the material still spinning around the sun. And then see how many other words you can add. I'm just going to run downstairs and get myself a big glass of water so that my voice lasts for the rest of this lesson, okay? So you've got the time it takes me to come back. remembered your words. The word beginning with A. Have you put these words on? Accretion, nebula, accretion disk. Well done if you spotted the spelling mistake, by the way, that someone spotted yesterday, and I've got to correct it. How are you getting on? Shall we go through it, and then you can be seeing if you can add accretion and nebula and accretion disk if you didn't add those things. Clouds of hydrogen and helium and some heavier elements. That's how our solar system begins. That cloud, because everything that has mass has gravity, that cloud starts to pull together because of gravity. So it starts to spin. You remember it sort of collapses in on itself, and a star is formed in the centre. Our sun is our nearest star. The sun is a star. So another thing you might get a mark for at GCSE. This happened 4.5 billion years ago and was the birth of our solar system. So over 99% of the nebula, this cloud, became the sun, and the something formed from the material still spinning around the sun. I mean, actually, if you know about astronomy, you could have said anything here. You could have said like comets or asteroid belt, but we've learned about the planets. The accretion, which bit of this is accretion? It's where gravity was... Oh, sorry. So the nebula is the name for this cloud of hydrogen and helium that the solar system starts as. Accretion is when it all starts pulling together. That's what accretion means. Oh yeah, warm water. And the accretion disk is the material still spinning around the sun. Okay, so have you got the answer to this yet? Hopefully the word accretion disk was your clue as to whether you'd got it right or not. Yeah, actually that diagram is wrong for some reasons, but it's correct in that the planets are orbiting the sun more or less on the same plane. It's not a simplified drawing. I mean, obviously they don't often like all line up very neatly like you see them in pictures, but they are all on the same plane because they all formed from this accretion disk that was going around the sun like this. It wasn't like an accretion cloud. All right, shall we move on? Because we're supposed to be talking about the whole solar system. And so far we've talked about the sun and we've talked about the planets. But there's far more to the solar system than just the planets. Let's dig a little deeper. Okay, so here are the planets. They are gorgeous. You do need to know what order they are in. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune is the handy little rhyme that I use to remember them. But what else is in the solar system? That was supposed to be a sort of rhetorical question, but I don't know. Can you name anything else in the solar system? It's not the kind of question I normally ask. It's a sort of slightly irritating, couldn't you think of anything better to ask me question, but go on. I'll give you 10 seconds. Dredge your brain. As many things as you can think of that are in the solar system that aren't the sun or the planet. All right, that's enough of that. Let's move on. Did you say dwarf planets? Oh, yeah, the dwarf planets are in the solar system. So the dwarf planets are also formed from the accretion disk. They're just quite small. They're smaller than the planets. The definition of a dwarf planet is that it hasn't done something called clearing its orbit. So if this is, I don't know, this like spoon is Jupiter and my head is the sun, Jupiter is the only thing orbiting on that exact path around the sun. Whereas a dwarf planet, if we say that like this coin is Pluto, then it's not the only thing doing that orbit. There's some other like bits of stuff that orbit that haven't like clumped together to be Pluto. So that's the one of the definitions of a dwarf planet, is that it's sort of rounded by gravity, but it can't clear its own path. So the asteroid belt is the bit that, anyway, I'll just put it down here. So the dwarf planets are Ceres, and then further back in the Kuiper belt you've got Pluto, Haumea, Makemake and Eris. You don't actually need to know their specific names. The asteroid belt here is between Mars and Jupiter. This is just a bit of the accretion disk that sort of got mucked up by being too close to Jupiter. So Jupiter is by far the largest planet. So because it's got a lot of mass, it's also got quite a strong force of gravity. These asteroids, they just can't clump together to form a planet because Jupiter keeps pulling on them. But Ceres is in there as well, one of the dwarf planets. Okay, what else? What else have we got? We've got moons. Obviously, moons are going round the planets. We've got asteroids, small rocky objects that orbit the sun, like I say, and we've got comets made of dust and ice. They orbit the sun. Most of them come from the Oort cloud. Do you know what the Oort cloud is? I feel like we're going too fast. We're talking, there's too much. So I've said in previous lessons, you need to know about the orbit of a comet. So we've covered so far, you needed to know that planets' orbits are quite elliptical, like an oval, but the word that we use is an ellipse because it's a special mathematical oval. The orbits of moons are more circular. The orbits of comets are really, really elliptical. So we'll talk about them now. I want to tell you loads more about comets. Comets are so interesting. If you go on my website where it says all ages, there you find all the all ages lessons I've done. Some of them go into really quite a lot of detail, like IGCSE level detail. If you go to the astronomy module that I've done, the all ages astronomy module, it's called Astronomy We Can See. I've got a whole lesson on comets. I'm really pleased with it. There's an activity where you stick toilet roll on paper and we talk about the difference between meteorites and meteoroids, and we learn about what a comet is, and I do like a whole model about a snowman melting. It's really good. I haven't got time to talk about that here, but we do get to talk about the Oort cloud a bit. Here is a picture of the Oort cloud. Behold and be staggered. So, the sun is in the centre of the solar system, yeah? It's the solar system. It's the system around the sun. So Earth is orbiting the sun. Obviously, we've talked about the planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So Neptune's right at the end. And then you've got the Kuiper belt where quite a lot of the dwarf planets are. And right on the outside, you've got this thing called the Oort cloud. So this is not a disk. This is a sphere. This is the very, very outskirts of our solar system. And this is where a lot of the comets come from. So just to give you an idea, thanks NASA for this picture. This little pink dot here is the sun. These are the planets going around the sun. So you can see, this is a good way of seeing, isn't it? That the orbits of the planets are not circles, they're elliptical. And the sun is not in the centre actually, it's just to one side. But this sort of cyan, light blue line here, that's the orbit of the comet. So it's ridiculously elliptical. Here's another diagram. Here you go. So what you need to know for your exam is comets move in elliptical orbits. There's another way of showing it. They move in elliptical orbits because they've come from really far away, and well, a lot of them have. I mean, actually, some of them have come from the Oort cloud, some of them have come from the Kuiper belt. But yeah, they've basically just got tugged on by Earth's gravity, by the gravity of Jupiter. Again, Jupiter's, you don't need to know this, it's just interesting. Jupiter's sort of messing with their orbit, so it's kind of flung them into this very long elliptical shape. Okay, can we end with 2 questions that I think I've given you enough information to work them out, but I haven't actually told you it. One of the questions is a bit... anyway, I'll show you it. Like and subscribe, chums, like and subscribe. Tough questions you've got enough information to work out the answer to, but haven't actually told you the answer. Why does everything in the solar system orbit the sun? Why does everything in the solar system orbit the sun? Now, you might say, well, they don't, do they? Like, Mars's moons don't orbit the sun, they orbit Mars. Yeah, that's true. But why do all the planets and everything else, why do they orbit the sun? And also, why aren't the rocky planets, Mercury, Venus, Earth and Mars, why aren't they as big as the gassy planets? Why aren't the rocky planets as big as the gassy planets? There were a lot of people giving me a really, really logical answer to this, but I don't think it would get a mark at GCSE, or you would definitely want to say something else as well. And why does everything in the solar system orbit the sun? I would encourage you, I guess, to write this down in case, because we need to practice writing stuff down if you're actually going to do IGCSE physics. So if you've got an answer for the last one, see if you can come up with another answer as well, yeah. Why aren't the rocky planets? Mercury, Venus, Earth and Mars. Why aren't they as big as the gassy planets? That's where our model failed, actually, isn't it? Because in my model, my lumps of rice are much bigger than any clumps of herb would be. Have you had a little think? Can I flip you around? Like and subscribe. Oh yeah, I should say, okay, just before we finish, I'll say that if you're watching live, then on my Facebook page at the moment, there is a post which you can comment on if you would like to. So there's no comments on these YouTube videos. But if you've got a Facebook account, you can go over to Facebook and say hello, and I'll read it out in a minute. If you haven't got a Facebook account, well done. It's the right answer. Facebook's well evil, and it's better that you're not on it. I know that you're watching because I can see the number in the corner of the screen, and I much appreciate it. Right. So the reason everything in the solar system orbits the sun is because the sun has by miles the largest gravitational pull, because the sun is made of 99% of the mass of the whole solar system. It's unbelievable. It's impossible to get your head around. The sun is made of 99% of the mass of the whole solar system. And the sun formed first, right? The sun formed first, and then the rest of the accretion disk clumped together around it to form the stuff. So it was orbiting, like, you know, Neptune was orbiting the sun before it became Neptune. Why aren't the rocky planets as big as the gassy planets? So a lot of people on Facebook yesterday were saying it's because gases, like the particles in gases, are more spread out than the particles in solids. And that is totally true, and we will do more about that in a later module, and it's a really good answer. So like, you know, the water particles in liquid water are quite close together, and if you boil water and it turns into a gas, the particles are much further apart. So that is true, but it's also true, and I was sort of trying to get at this when I was talking about how many herbs to put on your tray, that the nebula, the cloud that started out, that sort of gave birth to our solar system, if you like, it was mainly hydrogen and helium, remember, and just a few heavier elements. So there is more hydrogen and helium. There was more hydrogen and helium in the nebula, which formed to form the gassy planets, than there were like heavier metals, which is what formed the rocky planets. Whew! Right. It's also in your specification that you need to know these cool facts, but we will save these for next week. But I'll show you, because look at what's to come. Oh my goodness, so cool. You need to know that galaxies are each made up of billions of stars. So the sun is a star in the galaxy known as the Milky Way, but, well, yeah, anyway, we get to expand outwards. So we've done our solar system, everything going around our sun, but there are loads of stars all around us, really far away from us, but actually all collected together in this galaxy, which is called the Milky Way, which is just one of billions of galaxies. Anyway, more of that later. That is the end of my IGCSE physics lesson on the solar system. I hope that you enjoyed it. Thank you for coming. I'm going to go over to my Facebook page to see if anyone said hello, and I'm also going to do my ad, because I have to do my ad, because it's a good time to sign up. If you've been watching these lessons and you've been hearing me say that how it works is most people chip in £5 a month towards my wages, and that's what makes it be my job. That is true. If you've been thinking like, oh yeah, I should sign up to support Lara, yeah. Like, it's really great that she's a trained physics teacher with a first-class drama degree and a first-class science degree, and she's just streaming her lessons into the internet for free, and that's her full-time job and the only way that she makes money. That's really cool. I should sign up. If you've been thinking that, now's a really good time to sign up. I'm just looking at the comments. All right, Freya and Hannah, hello. Yeah, if you've been thinking that, now's a good time to sign up. How it works is, if you go to my About section, I don't know where it is. If you're on YouTube, the About section is like at the About tab. If you're on my website, just click sign up at the top. But if you sign up to support me on this website called Coffee, then I send you nice things, right? Because clearly this is the best job ever. Look at me. I'm not teaching in a classroom. This is literally my full-time job. I started, 5.5 years ago in lockdown, and you didn't want me to stop, and I didn't want to stop. So it's working really well for everyone. You go to the button that says sign up, send me £5 a month. It's enough to keep me going because there's enough of you watching, but hopefully £5 a month isn't too much from you. And I send you nice things to say thank you. So at this point, normally I say that I send you Theatre of Science magazine, and I will do that. If you sign up with £5 a month, you will get a copy of this past issue, which is on mould. So I write Theatre of Science magazine, but it takes me forever to write, like literally forever. I've been working on the latest one for like 3.5 billion years. So I'll send you this past issue to keep you going. It's about mould. You make a tray, you put some food in a home compostable plastic bag, you grow the mould, you identify it, you compost it all. There's a Choose Your Own Adventure, there's a beautiful comic, I'm very happy about it. If you support me with £6 a month, then you get this Christmas tree issue as well. It's just a pine tree issue, really. You don't need to celebrate Christmas. It's got pine tree bunting. I send you some string. You cut out the little bunting. You read the little tiny pine tree facts. It's so cute. It's got a beautiful pine tree spotting guide where if you're in like a garden centre over the next few weeks, if you're watching live, you might find a Christmas tree, a pine tree, answer all these questions, and it should tell you in the end what species you're looking at. It's got a gorgeous comic, and I'll send you some diffraction glasses as well, and some stuff about how they work, which will actually be quite useful if you're doing IGCSE physics, but they also make you see rainbows, so they're fun. Yes, husband and I suddenly had a brainwave. I think it was my idea, but we were chatting. We'd found this teeny tiny little free gift, and I was like, oh, that'd be a good free gift for the magazine. And then I was like, my supporters wait so long for Theatre of Science magazine because it takes me ages to write. Why don't we just post them this nice thing without the magazine? Why don't we just post them a nice thing just straight away? So obviously there's quite a lot of work to be done to just post someone a nice thing because there's loads of you. So husband's on it. He's right now. He's putting it together. It's going to be cool. So if you're watching live and you support me, if you send me £5 or £6 a month or more, some of you send more, then yeah, I'll tell you when to watch the post. But husband's in charge of this one. Not me. I'm just kind of telling him what to do and going, no, not do that. Oh yeah, put that in. So it should be with you a lot faster than the magazine is. Well, hopefully you'll have it in time for Christmas. Kai, I saw that message, but I was just about to go live. I'm sorry. I'm really excited. Yeah, I will. That's awesome. Yes, that's so cool. I will reply after this. Did we miss the answer about the orbit paths? Our laptop reset about the... Oh, do you mean like whether they're on one plane or whether they're all over the shop? Yeah, they're all on one plane because they form from the accretion disk. Accretion disk, what a great science word. So you've got a cloud, collapses to form the sun, disk of stuff still swirling around it. I always imagine like a blob of hot chocolate that hasn't dissolved with loads of sort of hot chocolate powder around it on the outside floating on top. The planet's formed from an accretion disk, a bit like that. All right, Bastian, hello. Science day for you. Hey, Freya and Hannah. And a comment on Freya and Hannah. Hannah says she only got the answer that there are more lighter elements and heavy elements. Nice, well done. Oh yeah, accretion disk is new to you. It doesn't get said a lot, does it? No, I only say the words accretion disk in these lessons. All right, Eve, hello again. Nice to see you. Not see you, that would be super creepy. You know what I mean. Hi, I missed the first lesson. Is that okay? Yeah, it's fine. Yeah, I've basically already told you what you need for you've definitely seen enough of these lessons to just be able to piece it together anyway. What did we do in the first lesson? We just looked at orbits basically, and like I've already recapped it a bit. Why did we need to do a whole lesson on orbits? I can't remember. I can't remember. It was a long one. We spent a long time doing things, and now I can't remember anything other than, yeah, the planets go around in an elliptical orbit and the moons are sort of circular. Sorry, if you came to the first lesson, that wasn't a lot, was it? All right, Thomas and Isabel and Lewis as well. Hey, hello, Lewis. Good to not see you. Hello. All right, Jacob. Hello. And there's Kai. And yeah, I will reply to you after this. I'll just click refresh just in case there's anyone else, but I don't think so. I changed my YouTube video to made for kids, like sort of saying all my videos are made for kids. But I don't know, I think I might have to change it back because like you're not really kids, are you? You're doing IGCSE. And I didn't really like having IGCSE. I liked having comments on these videos. Because, oh no, there's one more comment. Oh good, that is what you meant. Yeah, good. Yeah, so yeah, I might change it back again. Because it was like, I didn't sort of mention them too much because I know a lot of people watch on YouTube because they like that there's no comments, so it's not distracting. But it was kind of handy, like just having the occasional little answer pop up. I'll see. Oh, I'll look into the rules again. All right, you lot. I'm going to go and reset my Lego Story Show because if you like watching Theatre of Science on YouTube, then tomorrow at 9 o'clock in the morning, we've got our mythical mashup lesson. We're going to look at the DNA of a strawberry and talk about creatures that are different creatures kind of mashed together. And then at 10:30, the Lego Story Show is about the Sphinx. So I need to go and reset my story show for that. I nearly wiped that off the board. I won't wipe that off the board. because some wonderful people have signed up as I've been speaking. So I should just do one final thank you so much for sending me actual money so that I can do this job, because it's the only way anyone in my family makes money, and it's such a brilliant way to just look at me. I'm having such a good time. Yeah, right. So thank you for liking and subscribing. Thank you for liking and subscribing. When you say that, people like and subscribe. So thank you for liking and subscribing. Thank you for signing up on Coffee to send me actual money so that I can do this job. Thanks for joining in and just enjoying learning stuff with me. And I'll see you very soon. Bye.